Hello, I'm Tanya Chu. I am a physics tutor and at the same time, I'm also a YouTuber. So I make video upon request. So if you students have any videos that you want me to make on YouTube just for you, feel free to comment below. In this video, I am going to discuss Cambridge International AS Physics Paper 1 Multiple Choice February-March 2025, paper 1-2. So are you ready? Come, let us get started. Now let us begin with the first question itself. Number one, which quantity is a scalar quantity? Now, first thing you need to know is the definition of scalar quantity. What is the definition of scalar quantity? Scalar quantity is a quantity which consists of magnitude only. That's the definition of scalar quantity. Just a number and a unit. That's scalar quantity. Now let us look at the first one. Force. Force has direction, right? You have upward force, you have downward force, you have weight, which is acting downwards. Force is a vector quantity, not a scalar. B, momentum. Momentum is the product of mass and velocity. So since velocity, vector, velocity is a vector quantity, momentum will take vector. What about velocity? Velocity is a vector quantity. What about work? Work is the product of force and distance move in the direction of force, right? And work is a scalar quantity. The answer is D. Now, question number two. What is the effect of a systematic error on the measurement of a physical quantity? When you see the word, if you're confused, I want you to see this word. When you see the word systematic, this is related to system. System is related to apparatus. Right, let us look at A. It limits the precision of the measured value. Systematic error is the error on your apparatus. Like, for example, you forgot to minus the zero error on a micrometer screw gauge. You forgot to minus the zero error on the ammeter, voltmeter, etc. Right? It would not limit the precision because all the measurements, right, would have zero error included in your measurement. So all the measurement, depending on you as experimenter. So if you conduct the experiment correctly, so your precision, your data, right, all the data values will be close to each other. Right, what about B? It limits the range of values obtained in repeated measurement. It would not repeat the range of values because the range is actually depending on the apparatus. Right, C, it results in repeated measurements having different values from each other. It would not result having different values. It would not be like a big gap if you conduct the experiment carefully. Right, C is more to random error. Right, let us look at D. It results in the measured value being different from the correct value. Yes, all the measured value will be shifted, right? Either to be larger than the correct value or the true value, or all the measured values will be smaller. So all the errors will be shifted in one direction, we call that. So D is the answer. Number three, a car is accelerated by the constant force of 300 Newton for 5 seconds. Variation with time of the velocity in cm per second. Be careful with that. Cm per second of the car is shown. What is the mass of the car? Now, first of all, when a graph is being given, there are two information that you could obtain from the graph. This is a velocity time graph, right? So you have to understand if you want the mass, and velocity is being given and the force is being given, right? So try to think it easier. What have you learned in IGCSE? You have learned about this. F equals ma. You see that? So as long as you have acceleration, you can find the mass of the car. Now, this is a velocity time graph. How do you find acceleration from the graph? Very easy. It is the gradient of the graph. Gradient is equal to acceleration. So I better write it full. Acceleration. So for gradient, you need 2 points. So I'm going to take 2 points here. This is the first point. 5 and 150. But remember, this is cm per second. Force is Newton. You have to change a cm to meter. Right. And then the second point, this is 0 and 30. So I have to beware with my y-axis. So gradient is y2. This is x1, y1. This is x2, y2. Remember, for gradient, this is y2 minus y1 divided by x2 minus x1. So I got y2, which is 150 cm. Cm, you have to convert cm to meter. Remember, you divide by 100 or you times 10 to the power negative 2. Right, minus y1, which is 30 times 10 to the power negative 2 divided by x2 is 5, x1 is 0. I do not have to convert my time because my time is already measured in second. Right, so use your calculator. You should be able to get 0.24 meter per second square. Now, since we got the answer, all we need to do is just to sub in. Force is being given as 300 Newton. Mass, I don't know, but acceleration is 0.24. That is why my mass is equal to 300 divided by 0.24, which is equal to 1,250 kilogram. But I do not have the answer here. Therefore, I round it off to 1,300 kilogram. The answer is C. Now, question number 4. An aircraft initially stationary on a runway takes off with a speed of 85 kilometer per hour in a distance of no more than 1.2 kilometer. What is the minimum constant acceleration necessary for the aircraft? Now, I look at initially stationary, that means u is equal to 0, initial velocity is equal to 0, takes off with a speed. But I look at all the choices, A, B, C, D. Look at the units. The units are meter per second. It is necessary for me to convert kilometer per hour to meter per second. Now, I'm going to do that first. This is V. But my V is in kilometer. Just put it 85 kilometer per hour. Do it one by one. So 85, this is kilometer. How do you convert kilometer to meter? You just times 1,000. How do you convert hour to second? So you hour convert to minute first. This is 60. And 60 minutes convert to 60 seconds. You just times another 60. So you get a value there, which is, okay, I do it first. 85 divided by 85,000 divided by 3,600. So I got 23.61 meter per second. It doesn't matter because this is not my final answer. So I can write as many significant figures as I want. It doesn't matter. Now, the distance is 1.2 kilometers, so I'm going to change that, okay? Distance, or S, is equal to 1.2 kilometers, so I'm going to change it to meters. So 1.2 times 1,000, so 1,200 meter. Since I have the two values here, let me show you. This is a distance. I put it in meter, and my final velocity, I put it in meter per second. Right, now I can do it. There are a few kinematics equation which you can choose. Okay, I'm going to write this down. You have S equal to UT plus half AT squared. You have V is equal to U plus AT. And you also have V squared equal to U squared plus 2AS. In this case, out of these three equations, I am going to choose the third one. Why do I choose the third one? Because I do not have the value of the time. That is why I'm not going to waste my time. I'll just sub into whatever equation, whatever information that I have, right? I look at all the information, all the data that I have, and I choose the best kinematics equation to be used. So I'm going to use v squared is equal to u squared plus 2as. V squared is 23.61. I square the whole thing. U is equal to 0. Square 2a is the one that you have to find. Distance is 1,200 meter. So I just square it. Okay, I make a as a subject. So a is equal to 23.61, but you have to square it divided by 2 times 1,200. So then you get an answer. I square it first and then divide it by 2 times 1,200 and I got 0.23. Okay, 0.232 meter per second square. So the answer is A. Number 5, an object is fired outwards from a horizontal ground. The object has an initial velocity of 20 meters per second at an angle of 45 degrees to the horizontal. Air resistance is negligible. Which statement describes the speed of the object after it is fired until immediately before it reaches the ground again? Right. So when I look at the long statements like this, right, I got confused. Right. I would strongly suggest you, right, to draw a diagram like what I do. Right. So when I see an object, oh, this is an object, this is horizontal. Okay, this is the ground. And then the object is being fired outwards. Okay, with an angle. This is 45 degrees. Right? Initial velocity is 20 meter per second. And then air resistance is negligible. So this is more like projectile motion. So projectile motion, the object would be fired upwards, okay, going up and reach the highest point and then coming down to the ground again. This is the highest point. Highest point. Right? And then look at the question again. Which statement describes the speed of the object after it is being fired until immediately before reaching the ground? So before reaching the ground. So this is initial velocity. Now, let us look at A. Its speed decreases to a value greater than 0, then increases to 20 meters per second. Sounds confusing to me, right? So let me explain some certain important points on projectile motion. First of all, bear this in mind. I'm going to use the red color. So this is extra notes, extra tip for you. Bear in mind, horizontal. For projectile motion, you can actually divide it, right? Divided the velocity into horizontal and vertical direction. Horizontal component of velocity, right, is always constant. So it is always the same, right? The magnitude of the horizontal component of its velocity, always constant, same, right? And then, but, okay, this is the first thing, vertical component of velocity decreases to 0 at highest point. I will explain now why the vertical component decreases to 0. You see, right? When I resolve it at the highest point, I can only resolve this velocity to horizontal component, but never resolve it into vertical component. That is why it has to be 0. Vy is equal to 0 at the highest point. Right. And then one more thing, which is very, very important. At the same height, okay, speeds are the same. So you might wonder, what is the difference between speed and velocity? Speed is the magnitude of the velocity. Velocity is when you add direction, right? Speeds are the same. And the difference is direction. Let me show you. Okay, let's say I take the initial speed, okay, the speed at this point. Okay, I'm going to use different color to show you so that you can see it clearer. I'm going to use orange color right now. Could you see that at this point, I can, Okay, resolve it into two directions. Right? One is going up, okay? Vertical is going up, horizontal is going to the right. Right? So at this height, And then at the same height, you take it from the same height, you can also, okay, resolve it into two directions. It is just that the vertical is up, okay? At point A, I'll just write this point A, this is point B. At point A, the direction of the vertical component of the velocity is going upwards, but at B, the vertical direction component of that velocity is going downwards. The difference is just the direction, right? So if A value of the velocity, A value, the speed of A must be equal to the speed of B. Right, so let us look at A. Speed decreases to a value greater than zero, which is true. Why? Because the horizontal component of the velocity is the same all the time, but the vertical direction of the velocity, right, is decreasing to zero at the highest point. So that is why at the highest point, the velocity is not entirely equal to zero. It still has the velocity of vertical component. It's just getting lesser because velocity or the speed is combination of the horizontal and the horizontal component and the vertical component of the velocity. Right, let us look at B. Yes, A is true, right? Because at the highest point, it decreases to a value which is greater than zero because it still has horizontal component of the velocity. But after that highest point, it would increase again, but in the opposite direction. Right? B. Why B is not the answer? Because the speed decreases to a value greater than zero, which is true, but then increases to a value greater than 20 meter per second. It cannot be greater. It can be maximum the same. Right? So B is wrong. C, its speed decreases to zero. It cannot decreases to zero because at the highest point, right, there is still a horizontal component of speed. Right? C and D are both wrong. Now, question number 6. What is the statement of the principle of conservation of momentum for a system? A, the total momentum and the total kinetic energy are always conserved. Total momentum, total kinetic energy are always conserved. This is true for elastic collision. This is the statement for elastic collision. So it is not about the principle of conservation of momentum. B, the total momentum is conserved only in elastic collision. No, it is conserved in both elastic and inelastic collision. No. C, the total momentum is conserved provided that no external forces acting on it. This is definitely the statement of the principle of conservation of momentum. So this is correct. D, the total momentum of each object in the system is the product of mass and velocity. This is a definition of the linear momentum. This is a definition of the linear momentum. So D is not your answer. Now let us move on to question number 7. Object P and Q form an isolated system. Object P has a mass of 6 kilogram and it is moving at a speed of 3 meter per second. Object Q has a mass of 2 kilogram and it is moving at a speed of 4.2 meter per second at an angle of 35 degrees to the path of P. Object P and Q collides and stick together, right? This is definitely inelastic collision. I love to write that, right, to help me to remember. So what is the magnitude of the component of the final momentum of the combined objects in the original direction of P? In the original direction of P, don't you think that P is moving in the horizontal direction? So I want to resolve it into horizontal component. So horizontal, can I write it here? Okay, so I'm going to write it here. Horizontal, resolve it into horizontal component. P is moving to the right, so I will consider right direction as positive. Okay, one more thing which I need to write it for you. Consider right positive. So the left direction would take negative. Right, P is already moving to the right, and momentum, you remember the product of mass and velocity. So 6 times 3 initial momentum, right? Okay, plus, okay, let us look at Q. Q, if I want to resolve it, this is the direction of Q, right? The horizontal component, this is Q, right? This is the velocity of Q, 4.2 meter per second. So I need to resolve it, okay, into horizontal. Okay, let me write it down nicely. So this is the horizontal component. This is the vertical component. So this is the V. Okay, this is a U of Q. This is a horizontal. So I just resolve horizontal, yeah? So this is the angle of 35. Can you see that the direction of Q is towards left? So I have to put negative to its velocity, right? So the mass of Q is 2. The velocity of Q. Okay, so you want to resolve into horizontal direction. Adjacent over hypotenuse. Adjacent cos 35 degrees is equal to negative UQ horizontal over 4.2. So UQ is equal to negative 4.2 cos 35 degrees. So why do I put negative again? Because the initial velocity of Q can only be resolved into left direction. Left takes negative. So that is why negative 4.2 cos 35 is equal to these two objects sticks together. That is why you just add out their masses, 6 plus 2 kilogram, and time their final velocity. Right. And then oh, what is the magnitude? Oh, you are not finding the final velocity. They ask you to find the final momentum. Let me erase this. Get an answer. Get an answer first. Okay. So my answer for this one is 18 minus 6.88. And I got 11 kilogram meter per second. One more thing, and I want you to remember, same goes to elastic and inelastic collision. Total momentum before must always be equal to total momentum after. So total momentum before, I have resolved it into horizontal component, which is 11 kilogram meter per second, must also be equal to final momentum or total momentum after. That is why your answer is B. No further calculation needed. Now, question number 8. An astronaut of mass m in a spacecraft experiences a gravitational force F equals to mg when stationary on launch pad. What's the gravitational force on the astronaut when the spacecraft is launched vertically upwards with an acceleration of 0.2 gram? I want you to see this very, very carefully. They asked about gravitational force on the astronaut. What is the definition of the gravitational force? Gravitational force is actually the weight of the astronaut. Right, the weight of the astronaut, because even though the spacecraft is being launched with the acceleration of 0.2 gram, because the astronaut is still on Earth, that is why the weight of the astronaut is still equal to mg. Now, question number 9. The diagram shows a child X of mass 20 kilogram and a child Y of mass 15 kilograms seated on a uniform plane. The plane has a mass of 7 kilogram and has a pivot at its midpoint. Right. The plane is horizontal and equilibrium. This is a good keyword here. Yeah. And they ask you which is the correct statement. Which statement about the weight of the plank is correct? Right. The weight of the plank can be considered to be acting at its midpoint. Why? Because the pivot is acting at the midpoint, and the question already mentioned that the whole system, this plank, is horizontal. That means that, okay, you just consider these two, okay, weight of child X and the weight of child Y. When you see the word pivot, You need to know you have to use the principle of moment. What is the statement of the principle of moment? Principle of moment states that, right, when a system is in equilibrium, the total clockwise moment must be equal to anti-clockwise moment. So clockwise moment is being produced by child Y. Can you see? It follows the direction of a clock. So clockwise moment is, okay, I put here Y. Weight of Y, child Y, multiplies by the distance of Y. So you just multiplies. That is how we calculate moment. Must be equal to anti-clockwise moment, which is produced by child X. Weight of child X multiplies by the distance of child X from the pivot, which I put it as X. All right. So since the system is being balanced, the weight of the plank can be considered to be acting at midpoint. Because when the weight is acting at the midpoint, at exactly where your pivot is being placed, right, there is no moment for the weight of the plank, because there is no perpendicular direction from the pivot, because the pivot acts exactly at the weight. Now, be the weight of the plank is causing anti-clockwise moment, it would not cause anti-clockwise moment. It would not cause any direction of the moment, because the pivot is placed exactly at the center of gravity of the plank, which is on the exact point on where the weight is acting. So this is wrong. See, the weight of the plank is causing clockwise. No clockwise, no anti-clockwise moment. D, the weight of the plank equals to the force on the plank from the pivot. Where's the force on the plank? There is no force on the plank, only the weight of the two child, right? So this is also wrong. A is your answer. Number 10, an object is fully submerged in a liquid. A student determines the ratio upthrust force, upthrust acting on the object, divided by weight of the object to the weight of the object. Which single change would double the value of this ratio? Now, upthrust is equal to rho Vg. Rho means density of the liquid. V is the volume of the liquid, and G is the gravitational acceleration. Weight of the object is mg, the mass of the object times the gravitational acceleration. Now, let us look at A. Use a different liquid that has twice the density and same volume as the original liquid. Twice the density, 2 times the density, then you divide it, you get 2 times as large. Don't you think so? Because I want to double, that means 2 times larger. So now 2 rho, right? So this is, you just times the rho with 2, you get 2 times, right? A is the answer. Now, let me show you why B, C, and D are not the answer. Use a different object that has half the volume. If you have half the volume, right, you will get half of the original ratio. C, use a different object that has twice the density and same volume as the original object. If you use twice the density of the object, right, because the density of the object is not related to the ratio. It is the density of the liquid, so it would not double the value of this ratio. It would not even contribute to any, right, of this ratio. D, use a different object that has twice the volume and same density as the original object. I don't need twice the volume because the V is the volume of the liquid. So it won't contribute. It would not contribute to the ratio, right? That is not the answer. So A is the answer. Number 11, a shop sign weighing 75 Newton hangs from a frame attached to a vertical wall. The frame consists of a horizontal rod X, Y, and a rod YZ that is an angle of 30 degrees to the horizontal. Rod XY is attached to the wall by a hinge at X and has a length of 0.5 meter. Assume that the weights of the rods are negligible. What is the horizontal force exerted by the wall on rod XY? This is the one that they ask you to find here. Horizontal force by the wall. Now, when I see this word, okay, this is the tips that I want to share with you. When you see this word, let me highlight that word for you. Where's the word? Angle, attach. Okay, you see this word hinge, you see the word axle, right? You see the word pivot, fulcrum. You know that you have to use the principle of moment. And since the whole thing is in horizontal, right? I could say that I could use the principle of moment. Anti-clockwise moment is equal to clockwise moment. So I'm just going to write it down. Clockwise moment is equal to anti-clockwise moment. Clockwise moment, this is my weight. Weight is acting downwards, remember? Right, where's the hinge? Hinge is here. This is where my pivot point is. So going down, weight is acting downwards. While going downwards, turn towards the pivot on the left-hand side. When it turns in this way, this is clockwise moment, we call it. So it's clockwise moment, you have to use the force multiplies by perpendicular distance, which is 0.5, equal to anti-clockwise moment. This is the tension. Right? Tension, you need to resolve it into vertical and horizontal direction. So let me resolve. Okay, this is the vertical direction of the tension. I'm just going to do it here. Okay, this is the vertical component of the tension. I want you to remember this. Yeah, this is the vertical. Okay, keep my ruler first. Okay, this is tension vertical. And, okay, if I draw it again, yeah, I want you to see. Oh, my drawing skill is terrible. Right, I'm going to use orange color so that you can see. This is my tension right here. I can actually resolve it into two components. Right, if I use this triangle, this is 90 degrees. And do you know that this is 30 degrees? And this is 60 degrees. Right there. Right. If I want to resolve it into vertical direction of tension, this is vertical. All I need to do, I just take, okay, adjacent. Cos 60 degrees is equal to tension vertical divided by the value of tension. So the tension vertical is equal to T cos 60. So since this is T cos 60, okay, T cos 60 degrees, multiplies by perpendicular distance, can you see, which is 0.5. Make tension as the subject, find the value of tension, you should be able to get 150 Newton. Right, once you get the 150 Newton, remember the question asks you the horizontal force. Right, so horizontal force is the tension which is acting in horizontal direction, balance. You see, tension acting in horizontal direction is here, towards left. Right, the horizontal force by the wall is towards right, left and right balance. That is why the whole thing is in horizontal direction. That is why the whole thing is in equilibrium, not moving any direction. Right, so I use tension horizontal. Opposite, sine 60 is equal to tension horizontal over T. So T sine 60 is equal to tension in horizontal direction. So just use, okay, tension in horizontal, okay, which is T sine 60 is equal to force from the wall. Tension is given, okay, we have already calculated, remember? 60 is equal to force exerted by the wall, right? So the force exerted by the wall is equal to force wall is equal to 129.9 Newton, which I can round it off to 130 Newton. So the answer is C. Number 12, a student takes measurement to calculate density of a liquid in a beaker. The height of a liquid in the beaker is 0.2 meter plus minus 2%. Internal diameter of the beaker is 0.05 meter plus minus 3%. The mass of the liquid is 0.36 kilogram plus minus 10%. What is the percentage uncertainty in the calculated density of the liquid? Now, a lot of things to be processed, right? Don't worry. Just write down density. What is the definition of density? Mass per volume. Since the diameter is being given and the height is being given, and it told you that this is a beaker, right? So this is the beaker. You have to find the volume of the beaker, which is the volume of the cylinder, which is equal to pi r square height. So replace it with that, mass over pi r square h. And then, okay, bear this in mind. I don't have r, I only have the diameter. So you know that r is equal to diameter over 2. R square would be equal to diameter over 2 square it. So density mass over pi d over 2 square it h. Diameter, so density is equal to pi diameter square over 4 times h. Yeah, I am going to use this. Don't you think that this involves multiplication, power factor, as well as division, right? If all this being involved, how do you find the uncertainty? So the percentage uncertainty can be calculated by multiplies the fractional uncertainty with 100%. Now, since the equation involve power factor division and multiplication, I have to add the fractional uncertainty first. Delta rho over rho, right? If you want to find the percentage uncertainty, you just times 100. Is equal to delta m over m. You want to find percentage, you just times 100 plus pi is a constant. There is no fractional uncertainty, but d diameter. So diameter d square, power times the fractional uncertainty multiplies by 100 and plus delta h over h times 100%. So this is a percentage uncertainty of density. Delta m over m times 100%, that is the percentage uncertainty of mass, which is 10%. 2 times the percentage uncertainty of internal diameter, which is 3%, 2 times 3%, and plus with the percentage uncertainty of height, which is 2%. 10% plus 6% plus 2%, you get exactly 18%. The answer is D. Now, question number 13. The diagram shows a uniform plane XY of length 4 meter and weight 300 Newton. The plane rests on a fixed supports as at its ends, X and Y. A trial of 600 Newton stands in different position on the plane. The support at NX, where is NX? I better write it down first. NX exert a force F vertically upwards on the plane. What is the magnitude of force when the child stands at X and when the child stands at Y? Okay, when the child stands at X, right? So you could see that this force is being cancelled off because the child is standing on it. And okay, there are two forces acting. Okay, when child at X, right? So I want you to focus on X only. This is a plank. Okay, this is point X. This is a child. Okay, there are two forces acting at point X. One is the force, outward force, F. The other one is the weight of child, which is 600 Newton. Right. And then at the same time, okay, and then the weight of the plank is 300 Newton. Since this plank is uniform, so it would add at the center of the plank, which is 300 Newton, which is here. Right. So, and then the other one is the weight of the plank, which is 300 Newton. So, okay, since this plank is horizontal, you use the resultant force. Resultant force must be equal to 0. That also means that the upward force is balanced by the downward force. Upward force, I only have F. Downward force, we have 100 and, wait, upward force, I have, the weight is acting vertically on the plane. This is a weight, the child, and the child or weight stands at different position of the plane. The support exerts the force F vertically upwards on the plane. What is the magnitude of F when the child stands at X and when the child stands at Y? Oh, okay. Oh, way to do this, if I find the resultant force, right, I think the easiest way to do it is to find the resultant moment because the plank is horizontal. So I would say that the pivot is at this point, at point Y. This is my pivot. So all I need to do F, right? So identify all the forces first. F, 600 Newton, 300 Newton. And after that, look at F. F is acting outwards and pivot is on its right hand side. So F acting outwards while going to the pivot. This is clockwise moment. 600 Newton, which is the weight of the child, acting downwards while acting downwards going towards the pivot. This is clockwise, anti-clockwise moment. And 300 towards the pivot is also anti-clockwise moment. Use moment. That will be easiest way to do it. So anti-clockwise moment, clockwise moment is equal to total anti-clockwise moment. Clockwise moment is your force F multiplies by the length of the whole plank, which is 4 meters, equals to 600 Newton anti-clockwise multiplies by the length of the whole plank, which is 4 as well, and plus weight 300 multiplied by, because the weight of the plank is acting at the center of the plank, so that's why you just multiplies by 2. So when you get this, you have F times 4 is equal to 600 times 4, you get 2,400 plus 600. So F is equal to 2,400 plus 600 divided by 4, and you get 750 Newton. So could be C, could be D, right? So what happened if the child is at Y? Okay, can I continue from here? So when the child is at Y, this is the weight of the plank, which is 300 Newton, and this is Y, and the child is at Y. Now, and I want to find the force F. So I cannot set the pivot at X because I want to find the value of force F, right? So I would like to set my pivot at the center of the plank. Wait, this is my pivot. So I only involve two forces. This is the weight of the child acting downwards because there's no force on Y. So 600 Newton. And F is acting vertically upwards. I better write it nicely right here. Okay, this is F. F is acting vertically upwards. This is F. Okay, now use the same method. Clockwise moment is equal to anti-clockwise moment. Force towards the pivot, F towards the pivot, because pivot is on the right-hand side. That is why this is called clockwise moment. And 600 Newton towards the pivot. This is called anti-clock. This is called clockwise moment. And force, okay, sorry. Okay, now, since I have, wait, let me see this. Okay, my pivot is here. Okay, force is here, so this is clockwise, and the force, the pivot is here. So this is still, if I set my pivot 300, if I set my pivot at this point, why not I set my pivot at this point easier? Okay, because I don't get it here. So I would like to change my pivot because I don't get to use the principle of moment, and I really want to use the principle of moment. So this is a plank. Okay, the child is here at point X. Okay, because X and Y, they have already mentioned that supports at X and Y. So I will set my pivot, okay, at Y. This is Y, sorry, this is Y. This is Y, this is X, right? Set pivot at Y. Set pivot at Y. So I can ignore the force as what at Y. Right. Now I have force towards the pivot, F towards the pivot. This is clockwise moment. And 300 Newton, which is the weight of the plank towards the pivot. This is anti-clockwise moment. So I can use the principle of moment. Clockwise moment is equal to anti-clockwise moment. Write it nicely. clockwise moment, the force times the perpendicular distance, which is 4 meters, is equal to 300. Anti-clockwise moment, the force 300 Newton multiplies by 2. Why multiplies by 2? Because the weight of the plank acts exactly at the center of the plank. That is why F is equal to 300 times 2 divided by 4, and you get 150 Newton. D is the answer. Not easy, right? Number 14, which relationship is used in the derivation of the equation shown? Power is equal to force times velocity. Okay, first of all, we derive the equation of power. Power is being defined as work done over time. And the work is defined as the force multiplies by the distance moved in the direction of force. So force multiplies by the distance moved in the direction of force divided by time. I want you to see this very carefully. This is distance moved in the direction of force divided by time. This is V. Distance divided by time. P is equal to FV. And the distance moved in the direction is called displacement. Right? Displacement is equal to velocity multiplies by time, because velocity is equal to displacement over time. Right? That is the equation that we use. Now, number 15, a block is released from rest at the top of a slope inclined at an angle to the horizontal. The slope has length L as shown in the diagram. There are no resistive forces acting on the block, which is a good news. What is the speed of the block at the bottom of the slope? Now, first of all, we use the principle of conservation of energy. When the block is at the highest point, the block has GPE. No kinetic energy because this block is at rest. And when the block slides down the inclined plane, the block converts its GPE to kinetic energy. So I am going to use the principle of conservation of energy. GPE is being converted to KE. GPE is mgh, KE is half mv squared. You can just cancel it off. Now, GPE related to height, but in the diagram given, this is L. So I have to convert, or I have to relate H and L. This is a right angle triangle and the theta is being given. So H is related to sine theta, opposite of theta. Sine theta is equal to H over L. L is the hypotenuse. That is why H is equal to L sine theta. I just replace the H with L sine theta. So G, which is 9.81 times L sine theta, is equal to half V squared. So to find the V is equal to 9.81 multiplies by 2 and times L sine theta and square root the whole thing. So you just take 9.81 multiplies by 2, right? 9.81 multiplies by 2, you get 19.62. 19.62 L sine theta. Square root 19.62, you should be able to get 4.43 square root L sine theta. So the answer is B. Number 16, a skateboarder and her skateboard have a total mass of 70 kilogram. She pushes on the ground with her foot to create a forward force F of 25 Newton on herself and the skateboard as shown in the diagram. The skateboarder and the skateboard travel forwards a distance of 0.5 meter before the skateboarder leaves her foot from the ground. What is the work done by F on the skateboarder and the skateboard? Work is being defined as the force multiplies by the distance moved in the direction of force. Now, the force is 25. Distance moved in the direction of force is only 0.5 meter. So straight away you get the answer, 12.5 joules. I round it off to 13 joules. The answer is A. Number 17, a turbine at a hydroelectric power station is situated at a vertical distance of 30 meters below the level of the surface of a large lake. The water passes through the turbine at a rate of 340 meters cube per minute. The overall efficiency, see the word efficiency. So we're definitely going to use the equation of efficiency of the turbine and the generator system is 90%. The density of the water is 1000 kilogram per meter cube. What is the useful power output of the power station? Now, efficiency, this is a symbol of efficiency, eta. The name of the symbol is called eta, is equal to useful output power over input power and times 100%. I have efficiency, which is 90%. I don't have the input power. I'm supposed to find the output, but I don't have the input power. So I need to find my input power first. Right. Power is being defined as input power. Yeah. It is equal to work over time. Work done over time. And this work is equal to force multiplied by the distance moved in the direction of force divided by time. Is that okay? Work is equal to force multiplied by the distance moved in the direction of force. And, okay, I further do it. Force, upthrust force. Upthrust force is rho Vg times d over time. Now, okay, I find my input power. P input, rho is the density of the water, 1000, right? V is the volume, 340, right? G is 9.81, and the height is 30 meter. So this is 30 meter divided by time per minute. Can you see? 1 minute is equal to 60 seconds. So you find your input power, which is equal to 1.668 times 10 to the power of 6 watt. So I sub into this equation, I get 90% is equal to output power over 1.668 times 10 to the power of 6 watt times 100%. And make your output power as the subject, which is equal to 1.5 times 10 to the power of 6 watt. So B is the answer, 1.5 megawatt. Number 18, a projectile is launched at 45 degrees to the horizontal with an initial kinetic energy E. Assuming air resistance to be negligible, what will be the kinetic energy of the projectile when it reaches the highest point? Right, so I find the initial kinetic energy first. The initial kinetic energy, E initial, is equal to half mu squared. Right, so E is equal to half mu squared. Make this as my first equation. And this is a projectile and reaches the highest point. This is the highest point. Okay, E at the highest. So E at the highest, you have to bear in mind, because this is 45 degrees. E at the highest point is related to E horizontal, kinetic energy in the horizontal direction. Why? Because at the highest point, I can only resolve the velocity into horizontal direction, which is this direction. So E, I put E highest, is equal to 1 mu in the direction of x. This is u, I put this as u. And then if you want to find u in the direction of x, this is u. This is 45 degrees. And this is u in the direction of x. This is 90. So use cos theta. Cos 45 is equal to ux over u. That is why u in x direction is u cos 45 degrees. So E at the highest is half mu cos 45. You have to square it. So when you square it, I get half mu squared times cos 45 square it. Half mu squared is E. So E multiplies by cos 45 square. And cos 45, you square it, you should get 0.5 E. So A is the answer. Number 19, a wire is extended by a tensile force so that its deformation is elastic. What is meant by elastic deformation? Right, let us look at the first one. Extension of the wire is proportional to the tensile force. That is not elastic deformation. This is more like limit of proportionality at the region of limit of proportionality. So this is not your answer. B, the extension of the wire is not proportional to the tensile force. This is wrong. C, when the tensile force is removed, the wire does not return to its original length. This is called plastic deformation. Deformation. D, when the tensile force is removed, the wire returns to its original length. That is called elastic deformation. Now, question number 20. A bolt is subjected to a tensile force as shown. The bolt has a circular cross-section. At NX, the diameter is 2D. At NY, the diameter is D. And what is the ratio stress? What is the ratio stress at Y to the ratio stress at X? Okay, I have to find the stress at Y first. I use, this is my stress at Y. Stress is being defined as the force over cross-section A. But since A is diameter, so I have to relate to diameter. A is equal to 1 over 4 pi d squared. Right, or I use okay, because I relate this to circular cross-section. Yes, circular cross-section. So circle is pi r square. So pi r square, r is equal to d over 2, diameter over 2. That is why A, I have 1 over 4 pi d square. So sub in half over 1 over 4 pi d square. This is the stress at y. This is the stress at x, f over x. The diameter of x is 1 over 4 pi 2d squared. So I have f 1 over 4 pi 4d squared. This is the stress at x. So stress at y divided by stress x is equal to f over 1 over 4 pi d squared. I straight away invert it, multiplies by 1 over 4 pi 4d squared over f. So you cancel everything here. All you need to do, f and f can be cancelled off, 1 over 4 pi d squared, 1 over 4 pi d squared, and you left 4. So the answer is D. Question number 21. The graph shows the relationship between force acting on a compression spring and the change in length of the spring. One of the springs is placed in each corner of a horizontal square plate. The axis of each spring is in vertical direction. These four springs support a total load of 160 Newton. What is the total elastic potential energy stored in four springs? So I better draw out the diagram. So this is a plate. This is a plate, and the plates are being supported by four springs. One spring, two spring, three spring, and the fourth spring here, right here. And yeah, and total load, and okay, total load is 160 Newton. So now, since this is a graph of a spring, the force against change in length of one spring. So, and this load is being shared by four springs. So I take the force on one spring first, yeah? One spring is equal to 160 divided by 4, which is equal to 40 Newton. And from here, I need a spring constant because my elastic potential energy, EPE, is equal to half kx squared. I'm going to use that one. Right, now I need K, which is spring constant. Since this is a graph of force against change in length for one spring, so I look at 40 at K, okay, spring constant F equals to Kx, right? K is equal to gradient of the graph. So I take 2 points here, 0, 0, and this 40, and okay, take a value here. Right, so this value is 2.4 mm. Remember, this is mm. You want to find the energy, you have to convert mm to meter. 40 minus 0, force is in Newton, so I don't bother. 2.4 mm, negative 3 minus 0. So my K value is 1.67 times 10 to the power of 4 Newton per meter. Now, since I have my K value, I sub into this equation. 1 over 2, K is 1.67 times 10 to the power of 4. And then the extension is 2.4. 2.4 mm. So just square it. And you should be able to get 0.0481 joules, but this is only for one spring. They want 4 springs. So 4 springs, you just take 0.0481 multiplies by 4 and you get 0.19 joules. B is the answer. Number 22, which row correctly identifies the properties of all electromagnetic waves? Electromagnetic waves are all transverse wave, right? There is no longitudinal wave because longitudinal wave is related to sound, right? And electromagnetic waves can travel in free space, like ultraviolet, infrared from the sun. Yes, so the answer is A. Number 23, what is the approximate range of wavelengths in free space for infrared radiation? Now, the range of wavelength for IR, infrared, is about 7.8 times 10 to the power negative 7 to 1 times 10 to the power negative 3 meter. Let us look at the first one. First one is 100 nanometer. So 100 nanometer to 400 nanometer times 10 to the power 9. So you get 987. So 1 times 10 to the power of negative 7 to 4 times 10 to the power negative 7. This is not in the range of infrared. Now, what about B? 300 micrometer. 300 micrometer. Micro is 10 to the power negative 6, right? To 30 cm, negative 2 meter. So you get 654. 3 times 10 to the power of negative 4 to 1. 3 times 10 to the power negative 1 meter. This is also not true, not the range. 400 to 700 nanometer, this is visible light, right? This is visible light. This is a range of visible light. And D, 800 nanometer. Okay, I just put it in terms of the power of the prefixes. This is 800 times 10 to the power negative 9 to 1000. Micro is 10 to the power negative 6 meter. So you get 987, 8 times 10 to the power negative 7 to 6,543. 1 times 10 to the power negative 3 meter. Yes, the answer is exactly D. Number 24, the diagram shows a car traveling at a constant speed in a straight line between person P and person Q from point X to Y. The car sounds its horn continuously as it travels. The horn emits sound of constant frequency. Which statements about what person P and person Q hear during the motion of the car are correct? Person P hears the sound increasing frequency. This is not true because person P is at the back of the car and the car is moving away. This is Doppler effect. When the siren, okay, and when the horn is moving away, the person P will hear decreasing frequency. One is wrong. Number 2, the person Q hears the sound with the decreasing frequency. Car is moving towards person Q. So the person Q will hear the sound of increasing frequency. This is also wrong. 3, person Q always hears a sound of higher frequency than person P. This is definitely correct because the car is moving towards Q. Number 25, a progressive wave of frequency 300 Hz is traveling with a speed of 600 meter per second. What is the phase difference between the 2 points on the wave? There are a distance of 0.5 meter apart? I'll teach you the easiest way. Want to write the phase difference? It is given in degrees. So all you need to do is phase difference over 360 degrees is equal to path difference over lambda wavelength. So that's the reason why they give you the frequency and they give you the speed. Because from the equation of wave speed, F lambda, you can find the wavelength. Lambda is equal to speed over frequency. Speed is 600, frequency is 300. So your lambda would be equal to 2 meter. So sub in 360 degree, x is 0.5 meter, and lambda is equal to 2 meter. So very easy, cross multiplication. 360 times 0.5 divided by 2, that is your answer for your phase difference, which is 90 degrees. B is the answer. 26. A polarized beam of light with intensity I is incident normally on a polarizing filter. The transmitted light has intensity I. The filter is rotated about the normal axis through an angle of theta. Transmitted light has intensity 0.75 I. What is the angle theta? You have to use Morse law. So I is equal to I naught cos square theta. I is equal to 0.75 I, which is equal to I, transmitted intensity I, right? Cos square theta. So all you need to do is just to make cos square as the subject. Cos square theta is equal to 0.75 over I. I and I you can cancel off. So cos theta is equal to square root of 0.75 and theta is equal to shift cos square root of 0.75 and you should be able to get 30 degrees. Remember to change your calculator to degrees, not radian. Number 7, light waves are emitted from two sources. What is necessary condition for observable interference fringes to be produced? Observable interference fringes means you can see clearly which is bright fringe, which is a dark fringe, right? Now, A, the wave must be polarized. It doesn't matter whether it is polarized or non-polarized, right? You can still see the interference fringes. B, the wave must not be polarized. It doesn't matter. It doesn't matter. C, the wave must be coherent. This is very, very true in order for you to see the observable interference fringes, right? D, the waves must have equal amplitudes. If the waves have equal amplitudes, you could see, right, the clearest contrast of bright and dark fringes, constructive and destructive interference. Number 28. The diagram shows a water wave in a shallow tank. The wave is diffracted through a gap in the barrier and spreads. The wavelength of the wave is much smaller than the width of the gap. Wavelength of the wave and the width of the gap are both changed by small amount. Which combination of changes must increase the amount of spreading due to diffraction? If you want to increase, right, the diffraction pattern, you have to increase your wavelength, but decreasing the width of the gap to get the clearest diffraction pattern, to get the greatest diffraction pattern. Number 29, light of wavelength 567 nanometer is incident normally on a diffraction grating. The grating has 400 lines per millimeter. A number of diffraction maxima are observed on the far side of the grating. What is the angle between the second order maximum and the third order maximum? Now, this is what the question wants you to do here. So you see, this is my diffraction. This is my diffraction grating. I draw it. Okay, this is my diffraction grating, like this. And this is my light. And then this is a screen. This is called undeviated beam or zero order. So this is called, wait, Let me draw. This is a second order. This is a theta second order. This is second order. And this is the third order. Here, right here. So this is a third order. So this is a theta third order. So the question wants you to find the angle between these two theta. First step, you need to find the second order theta. So I am going to write down the equation of diffraction grating. D sine theta 2 is equal to 2 lambda. D is not given. They give you the number of lines per millimeter. D is equal to 1 over n. N represents the number of lines per meter. So find D. 1 over 400 lines per millimeter. 1 millimeter is 1 times 10 to the power negative 3. So you get your value, right? Which is 2.5 times 10 to the power of negative 6 meter. That is your D. Grating spacing. So this is 2.5 times 10 to the power of negative 6. Sine theta 2 is equal to 2 lambda. 567 times 10 to the power negative 9. Okay. Find your theta 2. Theta 2 is equal to 26.97 degrees. And after that, find your theta 3 using the same equation, but here you change it to 3 lambda, theta 3. So 2.5 times 10 to the power negative 6 sine theta 3 is equal to 3. 567 times 10 to the power negative 9. Theta 3 is equal to 42.87. 42.87 degrees. Right? So you want to find your theta is equal to theta 3 minus theta 2, which is equal to 42.87 minus 26.97. And round it off to the closest value, 15.9 degrees. So I get 15.9 degrees. C is the answer. Now, question number 30. Two cylindrical conductors, X and Y, are made from the same material. The conductors have equal lengths, but Y has a smaller diameter than X. X and Y are connected in series to a cell. Which row compares the number of charge carriers per unit time passing through X and through Y and compares the average drift speed of the charge carriers in X and Y? Now, when you see they ask you to find the average speed, straight away use this equation. I is equal to NA VQ. V represents the average drift speed. Q represents the charge. A represents the cross-sectional area. And N represents the number of charge density. I represents the current. Now, I want you to see this. Number of charge carriers per unit time. Number of charge, okay, per unit time. This is the definition of current. Current, which is I, right? And these two wires, X and Y, are connected in series. In series, current is always constant. So that is why Y same as X. B or D could be the answer. But the average drift speed, make the drift speed as the subject. B is equal to I over NAQ. I is a constant, right? What is the difference? Diameter is different. So I sub A. A is equal to 1 over 4 pi d squared. Is that okay? V is equal to I over N 1 over 4 pi d squared Q. I only compare D and V because everything else here are constant. Right. So diameter of Y is smaller than the diameter of X. So diameter of Y is smaller, average drift speed would be higher. Y would be greater than X. D is the answer. Number 31. A copper wire is 6.4 meter long and has a resistance of 0.92 ohm. Resistivity of the copper is 1.8 times 10 to the power negative 8 ohm meter. What is the diameter of the wire? Now, for question number 31, since the resistivity is being given, I would like to use R is equal to rho L over A. Rho represents resistivity, L represents the length of the wire, A represents the cross-sectional area of the wire. But in this case, the question asks for diameter of the wire. So A is equal to 1 over 4 pi d squared. Sub into the equation, d squared. Done. And, okay, I make d squared as the subject. R times 1 over 4 pi d squared is equal to rho L. D is equal to rho L divided by R times 1 over 4 pi, and you just square root it. D is equal to, rho represents resistivity, which is 1.8 times 10 to the power of negative 8, 1.8 times 10 to the power negative 8. L represents the length. The length of the wire is 6.4 meter over R is the resistance, which is 0.92 times 1 over 4 pi or 0.25 pi. So the diameter is 3.99 times 10 to the power of negative 4 meter. So you round it off to 4 times 10 to the power negative 4 meter, which is C. Number 32. A thermistor is connected to a cell with negligible internal resistance, which graph shows the variation with temperature of power P dissipated in the thermistor. Right, so you have to know that for thermistor, when the temperature increases, the resistance of the thermistor would decrease. Right, so power is equal to power. There are many equations of power. I write it down. Power is equal to IV. Power is equal to I square R. And power is also equal to V square over R. Now, due to the resistance that is decreasing, it will affect the current. That is why I'm using V square over R. Now, I need to know that when the temperature increases, the resistance of the thermistor decreases, but the power will have to increase. So the power is inversely proportional to the power and the temperature. So the power increases when the temperature increases, but you have to have a certain power, initial power, because the switch is closed. That is why the answer is A. Number 33, a metal electrical conductor has a resistance of 5.6 kilo ohm. Potential difference PD of 9 volt is applied across the ends. How many electrons pass a point in the conductor in 1 minute? I am using Ohm's law first. V equals to IR. V is 9. I find the value of current first. 5.6 times 10 to the power of 3. That is the value of the resistance. My current value is equal to 1.61. So sorry. This is 1.61 times 10 to the power of negative 3 ampere. How many electrons? So do you still remember Q? Kill it! Q is equal to IT, right? But Q represents the total charge. The total charge can be calculated from the number of electrons times the charge of one electron, because after all, it is not just one electrons that flow through the conductor. There are many electrons, but how many? Right? So equal to IT. So number of electrons divided by the charge. So number of the electrons, the current 1.61 times 10 to the power negative 3. In 1 minute, that is 60 seconds. You have to convert to second. Remember, yeah? And the charge of the electron can be taken from the data given. Right, so the answer is 6.03 times 10 to the power of 17, or 6 times 10 to the power of 17. Number 34, which circuit symbol does not represent an electric component that is designed to emit sound waves? Right, the one that is not designed to emit sound wave is B. B is called heater, to emit heat. Other than that, buzzer, right? The bell are all emitting sound waves. Number 35, the diagram shows a junction in a circuit where three wires P, Q, and R meet. The currents in P and Q are 1 ampere and 3 ampere respectively in the directions shown. How much charge passes a given point in wire R in a time of 5 seconds? Now, when a junction is being given, recall your Kirchhoff's first law. Still remember? At a given junction, the total current into the junction must be equal to the total current out from the junction. Right? So current into the junction, I only have 1 ampere. Current out from the junction, I have 3 plus, I just write I here, plus I. So the current across R would be I is equal to 1 minus 3, which is equal to negative 2 ampere. Right, but don't worry. Current and charge are both scalar quantity. Ignore the negative sign. Right, so how much charge? Calculate. Current, I just take 2, the magnitude, times the time, 5 seconds. So you get perfect 10 coulomb. C is the answer. Number 36, a cell of electromotive force, EMF, E, and internal resistance R is connected in series with a switch S and an external resistor of resistance R. The potential difference PD across P and Q is V. Right? Which statement is correct when S is changed from open to closed? When S is open, so what you get is that the EMF is actually equal to the PD across P and Q. But when the switch is closed, right? So the current will flow. When the current flow, some of the PD is being used across the internal resistance. Right? So V cannot be increasing. That's when the switch is open, that's the maximum V that you get. So when the switch is closed, you will get maximum value. You will get a decreased value. So C is also wrong because it cannot remain the same. It will have to decrease because there must be a potential difference across our internal resistance. So in a cell, due to the process of oxidation and reduction, right? Some of the energies, we call it as energy in physics, some of the work must be done to overcome this. Number 37, what is the general description of a baryon? So still remember, baryons consist of 3 quarks. Right? So first one, A, it consists of 3 quarks and all the quarks must be of the same flavor. No. Don't need to be same flavor. Some of the quarks has different flavor, right? B, it consists of 3 quarks, which is true, and do not need to be the same flavor. Yes, B is the exact answer. Now, 38. A stationary nucleus has nucleon number A. The nucleus decays by emitting a proton with a speed v to form new nucleus with speed u. The new nucleus and the proton move away from one another in opposite direction. Which equation gives a v in terms of A and u? So I just write down A, this is x, decay, right? Okay, opposite directions. So I better draw opposite directions. Okay. Okay, draw it again. This is A, X. Okay, I get this. I get this. This is emitting a proton 1,1H with V. And then a new nucleus. I put A minus 1. This is Y. And with the speed U. Right? So I use the principle of conservation of momentum. So start from 0, right? Okay, move in the opposite direction. So this is A minus 1, the mass. Okay, A minus 1. Okay, times negative U plus, okay, 1 times V. So V is equal to, this negative U, when I shift it to the left-hand side, it will give you principle of conservation of momentum for explosion, right? You start from zero and then move in the opposite direction. Momentum is a vector quantity. You have to put in minus 1. Sorry, not A minus U. This is A minus 1. A minus 1. That is the mass number. Remember, nuclear number represents the mass. A minus 1. So A minus 1, negative U becomes U. So the answer is B. Number 39. What is the change to the quark composition of a nucleus that takes place during beta plus decay? So I always write beta plus first. This is how I do it. And then plus neutrino. Beta plus is 0, positive 1, right? So I need to have something that add with the positive 1, neutron, right? The decay of proton that give rise to neutron, right? Protons, the quark is up, up, down. Neutron, the quarks, right, are down, down, up. So an up quark changed to a down quark. So up to down. D is the answer. Number 40. What is the charge in terms of elementary charge E on a charm quark? Charm is positive 2 over 3E. Right? That is all about our discussion on AS Physics, paper 1. Paper 1 to February, March 2025. So if you need the free solution, okay, free sample answer, right, free working, right, for this paper, all you need to do is just to hit that subscribe button and comment yes, and I will send it to you personally. Thank you very much for watching, and I'll see you in my next video. Bye.